Thank you very much for coming back. As I said at the beginning, it's my ambition today, and this is a tough part for me to speak as little as is humanly possible. I'm just going to give a very brief introduction to the OpenSAFELY platform, which I think is a genuinely historic contribution to data infrastructure. The UK has the most extraordinary data of anywhere. In GP data alone, we have one record for every citizen going back decades, with one row for every significant clinical event, every diagnosis, every treatment, every prescription, every blood test. And we don't just have an enormous scale of data on a complete population, we also have a very ethnically diverse population. And that means that data from British electronic health records can generate insights into ways that we can prevent suffering and death that aren't just relevant in this country, but that are relevant around the world. Now, historically, it's always been very challenging to work with that data. Because the problem is, the self-same data that contains all of the information you want to understand ways to optimize the logistics and delivery of healthcare, the causes of disease, the benefits and hazards of treatments, that self-same data also contains the deepest and most private secrets of every citizen in the country. Now, historically, the ways that we've tried to work around that have been primarily self-standard. We've taken names and addresses of people's records, disseminating them out very widely. And because we knew, sometimes tacitly, sometimes explicitly, that that wasn't a sufficiently good privacy mitigation, we imposed incredibly slow and cumbersome information governance processes to try and manage those privacy risks with contracts, with trust, and with promises. Now, the problem with contracts and trust and promises is that they're simple. If we want to see better, broader, safer use of health data, if we want to see an enormous explosion in the number of people who work with data, to detect the crucial signals from those prevent suffering and death around the world, then we have to do better than artificially planning. So, at the beginning of the COVID pandemic, we could see that there was a problem around access to primary care records. The entirety of wave 1 of the pandemic came and went, and I think also wave 2, before a single death appeared in any of the traditional data extraction and dissemination services that were available to GP data. Now, at the time, in March 2020, none of us knew that it was going to be a 1, 2, 3 year pandemic. In the same way that in 1939, they didn't know that it was 1939 to 45 war. And we were frightened. And we didn't know what was going to happen. And a small group of us came together and plotted what you will hear about today, which has now grown into an enormous collaboration. A collaboration across disciplines, everybody loves to say, here at home you can see it's really truly with software developers combining skills and knowledge with electronic health records researchers, analysts and statisticians. But also across organisations. We first built our tools inside the data centre of TPPs, who worked with us for free, pro bono, giving enormous amounts of resource and time and energy to the project. We also worked with NHS England as data controller, and we've also worked with a growing band initially in London School of Hygiene and Tropical Medicine, always my lead brand for electronic health records research, at least at the and now we've expanded to cover Bristol, Manchester, the amazing chair Ben Goldacre, previously head of research at CPRD, and we now have over 150 projects from over 22 organisations, including universities, but also NICE, UK Health Security Agency, Office of National Statistics, and more. So, without further ado, OpenSAFELY, not just what we did with it, but how we used it.
Okay. Right, hi, I'm Ben Goldacre, I'm CTO at the Bennett Conference, Chief Officer, and I'm going to give you a high-level overview of how OpenSAFELY works. So, what is it? It's a layer of software, tools and services that can be put in front of any database, which leads to a misconception that it's a database. It isn't a database. What we do is we give researchers arm's-length access to unprecedented amounts of data via the databases maintained by our friends at TPP, who are the providers of the two biggest GP health record systems. They're the two that we're talking towards the end of that. We've also installed it in other databases, but today I'm just going to talk about the Jewel and Crown, which is the primary database. So I'm going to start with data, because that's what people tend to notice first. So we've got access, arm's-length access, to 58 million patients' data, which is almost every patient in England, updated every week. For each patient, we've got access to the most granular raw data, every diagnosis, every test, prescription, and so on, and that's more than 70 billion rows of data altogether. And data at that level of detail and scale isn't available anywhere else in the world. On top of that, we give access to a wide range of other linked data sets that can tell us even more about each patient. So, for example, HES, HES, hospital episode statistics, which I'll be mentioning a little bit more, A&E data, death register data, and so on. And we don't just link onto health data, we link onto other research data sets, including trial data and registries. So, for example, with our partners at the London School of Tropical Medicine and TPP, we're doing a really exciting project about long COVID, which is what we're doing is we're asking patients to actually report their quality of life over a mobile phone app. And that data is automatically getting linked to all the data in their GP record for us to examine outcomes. So, this is an unprecedented volume of data, but we didn't get it by magic. We earned it by building new methods and tools to manage privacy risks. That's what I'm going to talk about next. So, long before the pandemic, we actually identified four core problems in our data research that we wanted to fix. And they are privacy, transparency, efficiency, and reproducibility. We're actually really obsessed with efficiency and reproducibility, all that stuff we talk about, open methods and so on, because we think they accelerate really great science. But we can't really address those two before we deal with the first two, mission critical blocker problems about how to access really sensitive data. So people want to know that their private records are kept private, and they want to know what their records are used for. And privacy is really important because we won't earn and keep the consent of the public to use their data to unlock all the huge health benefits we know about. And without transparency, our claims about privacy are just claims, they're just speculative, they're just saying, trust us. And people might be demand to be able to verify claims like this. So just starting with privacy. The problem with health data is it's so detailed. So Ben was saying earlier, even when you take names and addresses out of the data, which is called pseudonymization, if you already know a few things about someone, it's easy to narrow down all the available data about everyone to information about that person. And this is particularly true for famous people. For example, Tony Blair had an abnormal heart rate reset in 2003 and 2004. And that HES data set I mentioned earlier, until recently, that was routinely sent to approved researchers on a DVP. So there might be people in this room who've got that DVP at work. And information about Tony Blair's heart scares going to be on that DVP. If we search that data, that data has been pseudonymized, or it doesn't mention Tony Blair in it. If we search that data for individuals who match all of that information, which is all public domain, you'll probably, if you're actually on this, you probably only get one person. And that means you can find out all the other things about that person. Most researchers write code in a language called SQL, and you will know how to do this, and purely just for the rhetorical joy of it, we've actually written the SQL you would run to find out all the code that. So we're not all as famous as Tony Blair, but we all know people who know something about us. Perhaps when you get birth, when you move to the area you live in, where you move from. And these people could be someone at the school gate, they could be an acquaintance, they could be an emergency centre partner. And although obviously epidemiologists are extremely trusted people, we have to recognise that misuse of data is a small but legitimate risk. And that's important, we need to show we're actively recognising and managing that risk to other countries. So, what do we actually do in OpenSAFELY to mitigate these risks? So it's now largely agreed we have to move away from the old model where data is set out to be researched on the DVD so that they can work with it in an unconstrained way on a laptop. And instead, it's widely agreed now that we should impose a requirement that data doesn't leave safe locations. So most secure research environments offer what's called a remote desktop TRE, trusted research environment, which is a system where you securely log into a secure computer managed by a trusted third party. And you're given access to an extract of data that is analogous to the DVD. Now that's definitely better than sending data outside the secure environment. In OpenSAFELY, we wanted to develop a way to access that data at arm's length. When you go and see a doctor at GP surgery, they talk to you, they make a diagnosis, that gets entered on your health record. So here, on the right, you can see an asthma diagnosis being added to someone's record. Every prescription, every appointment, every single event gets added here. So there, bottom is an inhaler. Researchers work with the detailed data set and then process it into a less detailed data set to use in their work. Instead of being one row per event, that contains one row per each patient. And this work in making this condensed summary data set is sometimes called data curation. And I'm just going to get a little bit technical to illustrate it, just to give you an example of what it means. So here's a simplified volume of what we call the raw, simplified version of what we call the raw event level data with like values. So the column headings on the top in dark blue are patient identifier, code of the event, description of the event. So here it's knee pain, asthma diagnosis, and inhaler prescription, that third one. Date and the practice where it happened. And we've shown 3 different events here. Bear in mind, in reality, there's more than 70 million. Each row represents a single event. So the top 2 rows in light blue show someone who had a symptom of knee pain in 2002 and a diagnosis of asthma in 2008. The green row is an event where another patient was prescribed an inhaler. And in contrast, you can see that was just last week. So let's say the researcher is interested in if each patient they're studying is likely to have asthma right now. They need to convert the raw event level data at the top into a smaller data set. This is the active curation. And that contains 1 row per patient, which is 2 rows in it. And those rows indicate that each patient probably has asthma or not right now. So in this case, the process is matched the second green patient because the first patient, although they got an asthma diagnosis, that was 15 years ago. Right, so as Ben said earlier, in most environments right till now, the way we manage that risk is by having necessary detailed and slow and difficult information governance processes because we're giving them unconstrained access to that event level data, very detailed data, it's potentially dangerous. But the key stage aim of government and the NHS is to get more people working on the data, and that means we need to be better than that, better risk mitigations. So here's how the system itself goes. The first step is, as a researcher, you don't do curation work directly on the real data at all. Instead, the OpenSAFELY robot provides you fake data, the same structure and high-level features of the real event level data, but this is randomly generated. So there's guaranteed to be no criticisms. Researchers get to work with that data, and that data is good enough that they can write a lot of that code. The OpenSAFELY robot comes along, and it takes your code, and it takes it into a secure environment on your behalf. The robot runs the code for you, and no analyst ever enters the secure environment where the data lives. Instead, the robot brings outputs back to you. This might be visualization, or it might be log files for working out what went wrong and something unexpected happened, or it might be results of an analysis. So that's the basic principle underlying how OpenSAFELY works, and it's a great design, but there's still another problem we want to solve, which goes back to that thing I was saying. Make this amazing system, just trust us. We know what we're doing. And we think that's not good enough, we've always got to work at being proving that what we do is what we say we do. So first of all, the platform itself, all the code is online in GitHub. It's all really tested, it's very good, it's documented, it's useful code, by the way. It's nicest code base I've ever worked on. Thanks to like the most amazing engineers we've got in our team. Some of whom we'll be talking a little bit. And also, every version of every bit of research code that has everything run against real nation data is guaranteed by the design of the platform to be shared. This is actually my favourite thing about OpenSAFELY. Just talk about that another time. That's great, but we're still kind of saying trust us. So can we do better than that? We aim to earn the trust through transparency, and we principally do that through auditable public ones. Anyone can visit our public dashboard. That's what it looks like. You can go to that, someone's going to be talking about that in a little bit. For the job server, and anyone can go there and see what's going on at any time in the secure environments provided by TPP and EMIS. We call it backends. And it's where research interacts with web on that website as well. That's in a minute too. So in this screenshot, you can see three things recently handled by the robot. So the most recent at the top had an error. The next one had a green tick completed successfully. And the last one was still running into the screenshot. You can see information about each project, who the robot ran the job for, how long it took. You can click through on each of those, you can get loads more information, technical detail about what the robot was doing, the code it used, and this audit trail is available for all interactions with real data ever. Alongside the precise version of the code that was run, and all the outputs that have been verified to save to release. So it's all together in one place. The research outputs, the code that was run, and when it was run, and the period ran, all in one place for public inspection. So this is obviously really important for proving all the privacy and transparency, but there's also another important consequence that flows from this. Because all the code is by design guaranteed to be shared, that enables the widest possible standardization of use. So I've been describing data curation a lot. That's the job the researcher has to do to work with standard data, beginning and end. And this is usually done on a per project basis using programming languages like SQL, R, Python. And this work usually has loads of overlap between projects. People are often trying to do very similar things and identify people with the recent and possible asthma. But the code itself in the past is rarely shared between projects, and everyone does it slightly differently. So that's why all the tools we've made and all our future plans focus on standardization, automation, and code sharing, because we want to make it easy for people to work in open, easy for them to share their methods, and easy to be part of the community that's doing that. Finally, I want to mention what's often called federated analytics. It has a few different definitions, but I'm going to say federation is any system that allows researchers to write code once and then run it in multiple locations where sensitive data is stored. So it just so happens that the standardization and automation that I've just been describing is federated analytics just works. That means primary care data, which is the most sensitive data we ever analyze, now has to relieve the secure environment that was originally stored, which is really important because every time you make a copy of data and you move it around, you're increasing the risk of leaking that data. So federation minimizes that risk, allows the data around less, and it maximizes code reuse because it has a single piece of code to use everywhere. This diagram is on our documentation online, but fundamentally it's just illustrating that in a simplified format. On the left, we've got a single code base, and the code is spotted into two backends at the top and bottom. There's one for TPP, there's one for EMIS, the two databases. Then each of those backends can store the data in completely different ways. OpenSAFELY deals with those differences for you. Results are checked to ensure they're safe for release, and then the two sets of results are combined. That's what this is going on. So that's it. It's a whistle-stop tour of OpenSAFELY. I'm talking later with any more details on that short Q&A. Next up, we're going to do some lightning talks covering some of the tools we made that I mentioned. And then after those, there's my technical talks. We're going to have a series of talks about the OpenSAFELY Service Wrapper, which is all of the kind of user support that we do. Because on its own, the software would be nothing really, even though it's amazing. The secret of the success of the service wrapper too. So that's what we've got coming up next. Thanks for listening.
Hi, I represent the software developer at the Bennett Conference. I'm going to talk about CodeLists and I'd like to start by thinking about a question. So, given a patient's clinical records, how do we know that they have asthma? When doctors enter information into a patient's health record, they use codes from standardized coding system. But determining whether a patient has a diagnosis is as simple as just looking up the term in a database. Snowman CC is one such coding system. It contains over 500,000 it's a comprehensive catalogue of concepts, including disorders, body parts, occupations, physical objects, places, animals, and with rich yet strangely incomplete taxonomy. This is a snapshot of Snowman codes related to asthma. At the latest count, there are 661 codes whose descriptions contain the word asthma. A diagnosis could be encoded in many ways. Different doctors will report it differently. The researchers need a list of codes that identify different ways that an asthma diagnosis might be coded. A naive approach would be to take all the codes whose descriptions contain the word asthma. However, not all of those codes will indicate an asthma diagnosis. Somebody who's been recorded as being at risk of asthma doesn't necessarily have asthma. Cardiac asthma is something that affects people with congestive heart failure. And a record of childhood asthma doesn't necessarily mean that the patient has asthma today. Given an existing code list, it's relatively easy for somebody with clinical expertise to manually check and ensure that it doesn't have any codes that it shouldn't. But without knowing how the code list was created, it's impossible to check to ensure that it isn't missing any codes that it should have. Remember, there are hundreds of thousands of Snowman codes. So OpenCodelists is our tool for managing code lists. It began life as a repository for CSV files that could take code lists used in the original OpenSAFELY research. And given the importance that we attach to reproducible research, we think it's essential that researchers share their code lists as well as their code, and we need a place to store them. But OpenCodelists has grown from a place for storing and sharing code lists to a place where researchers can create and maintain them. So this video is showing the beginning of the creation of massive code lists, like the one we looked at earlier. So we can create a code list, giving it a name and choosing a coding system. Then we can start to build the code list by searching for the coding system for the term asthma. This brings back all 661 asthma-related codes in Snowman. And we can decide which ones to include and exclude. So you can click on the plus to include all codes of the asthma disorder, and then we can click on minus for childhood asthma, because we want to exclude that code from the code list for asthma diagnosis. Importantly, OpenCodelists doesn't just store static lists of codes. It also records the search strategies used to build the code list and the decisions of which codes to include and exclude. We can reconstruct the reasoning behind codes, which is essential for our goal of making code lists more useful. It also means we can generate new versions of code lists when the underlying code systems are updated. Today, OpenCodelists supports multiple code systems, and it now hosts over 5,000 code lists from over 350 users.
I'm Peter. I'm the I lead the data team at the Bennett Conference. And I want to show you at a very high level how you can ask questions of patient data using ehrQL, new query language designed for querying ehr data within the OpenSAFELY platform. ehr is a electronic health record. So in OpenSAFELY, patient data lives in the database in the OpenSAFELY backend, such as TDP or Englesby. You can submit query code written in ehrQL to the backend, and you get that information about a subset of patients in the backend database. We call the results a dataset, and as test shown is a table of data with one row per patient, one column per each of interest. So that's what that was for. I want to talk a bit about why we've created it. And among other things, we've designed ehrQL to be portable, reusable, and readable, And to explain what I mean by this, I want to give you a small example and show you a small fragment of code. So this fragment asks that each patient has had an asthma diagnosis in the last 5 years. Notice there's nothing here that's specific to the OpenSAFELY backend. EMIS and GDP have made quite different decisions about how to structure their data. For instance, you can give it table names and column names. The ehrQL engine knows how to take a local query and make it run on anything at the backend, allowing a kind of federation that's set to talk back. In other words, ehrQL is supported. This is in contrast to SQL, where different dialects and differences in table and column names mean that you have to write separate queries for each backend. Now let's break this fragment down. We start with a table of clinical events, things like observations and diagnoses. We filter it to include just the events whose code is in an absent code list of the kind that they can talk about. We then filter it again to remove any events that occurred more than 5 years ago. And then we can ask for each occasion whether any matching events exist. Then we can give the result a name, allowing us to make use of the data on. For instance, if we have another similar query called has recent prescriptions, we can combine the two to get a clearer picture of whether each patient has asthma. Being able to break queries down into small chunks makes the language mostly composable, which, along with it being portable, makes it easy to reuse queries or parts of queries across a study or even between studies. And again, this is in contrast to SQL, which is designed to make it quite hard to break queries out for reuse. You can imagine a library of common variables for all kinds of different clinical conditions, designed for different purposes, and researchers could pick them off the shelf in the way that they do now with focus. Once researchers satisfy themselves that a variable from the library does what they need it to do, they can make use of it with just one line of code. We're not quite there yet, but that's one direction we plan to take our work in. Now, going back to our code fragment, although it's a little verbose, we do think it's quite readable. Things are named clearly, there's no strange code. It's clear what each part of the code contributes to the query, and so on. And again, this is in contrast to SQL, where big queries can quickly become very hard to reason about. One reason we achieved this is because we haven't set out to build a general purpose query language. We understand our domain really well, and we put effort into making the language fit the domain. There's a lot more I could talk about how it would be used outside research, about the architecture and implementation of the open engine, as well as our approach to testing and coding. So keep an eye out for blog posts on those in the future, or come find me during this. Anyway, thank you.
Hello, my name is Simon Davy. I am a software engineer at Bennett Conference, and I want to talk to you about how Seb's robot actually works. So I'm going to imagine that we have some code lists that we've already defined using OpenCodelists that Becky talked about. We've also got some ehrQL that we've written to define our data set. I'm also going to assume you maybe written some custom analysis code to analyze that data set to find out what we're interested in. So how do we actually test and run this? So this screenshot here is a screenshot of code, a tool called Visual Studio Code, which is a popular code editor. And this is the idea here to give you an idea of what it looks like to work with the OpenSAFELY tool and the OpenSAFELY platform. So, firstly, we need to capture our desired data flow in what we call a project file. And here we can find an action that runs the ehrQL tool using the dataset definition that we have generated, and outputs a file, dataset.arrow is a common data file format. And this output we list as being highly sensitive. That means it contains this one patient per row data that could be exposed information. So this data cannot be accessed by the researchers at any point, it's just stored in the system for data use. Then we define a second action, and this is our custom Python analysis code that we've written. It might run a statistical model on your code, or it might plot some charts or some graphs so you can understand it better. And this requires the file of the previous action, so we declare that this one needs to run after the previous one, we need that file available to it. So we say that it needs to generate dataset action. And this action also has some outputs. It outputs a summary CSV file of your statistical model or whatever it is you've done. And this will be marked as moderately sensitive, which means that it is available for researchers to look at and can potentially be output checked and then released to be able to talk about later. So, you've written your project file and you can test and run it locally on your computer using some of the OpenSAFELY tools. So you can type the command OpenSAFELY run and it will run your code. And what it's doing here is it's running the ehrQL dataset using the fake dummy data that Seb talked about. And it is using exactly the same environment and the same libraries of all the libraries that you've used as will do in production. And when that is finished running, you will have local files that are versions of files using the dummy data, and you can inspect them and check that they're valid, check that they map your expectations. And this whole process of running locally allows you to ensure that your code and your project file execute without error. And allows you to develop and debug your code locally, as well as collaborate with others who can also run your code that you've written on their machine using these tools. And now you can save this tested and working code to GitHub and then submit it to run against the real data. To do that, you log on to the main entry point to the OpenSAFELY platform, which is jobs.opensafely.org. And you go to the project that you're working on and you click a button called Run Jobs. And you get a screen that looks a bit like this. And you can select which secure backend you would like to run your job in. And you can select which of the actions you may wish to run. You can see here it's picked up that we've got our two actions we've defined. Tick there means that it has run successfully previously. And we can run all of them from one job, we can just run a subset. When this happens, as your code runs, on the jobs OpenSAFELY site, there is a page for every job that's running that tells you the status of the job. And you can use this to monitor your jobs, to check that they're working. If there's any errors, it will give you a clue as to what's gone wrong, where you need to look to find out more. But this page is also public audit trail, as Seb was talking about earlier. And this page is viewable by anybody. You don't have to be logged into the site to see this. And they can see who ran what code and what detail. And you click on the link so you can look at the actual code in GitHub that was run. And it's a very important part of our transparency pillar that Seb was talking about. And that's how you write new code on OpenSAFELY. Thank you.
I'm Catherine, and I'm the product manager for OpenSAFELY, and I'm going to be talking about a new tool called OpenSAFELY Interactive. So you've seen how researchers experience OpenSAFELY end-to-end, but the technical aspects can be quite intimidating. So we ask ourselves, could we enable people to use the system without writing code, while still keeping all the privacy and transparency benefits? I'm working on this with our friends on the primary care medicines and analytics unit at OpenSAFELY Interactive is a web-based tool designed to run analyses without the need to write code. Because I lead product management at OpenSAFELY, I am very focused on understanding how users will ultimately get value from our tools. And having spoken to a variety of potential users, here is an imaginary example of the kind of use case we decided to focus on first. Tanya, our imaginary user, leads a quality improvement team in NHS England at national level. She can see on open prescribing that antibiotic prescribing went up at the start of the pandemic, but she wants to dig deeper to understand why and if it's an ongoing issue. Were certain groups, such as people with COPD, more likely to get these antibiotics? Was that entirely down to rescue packs provided during the lockdowns? And she's particularly interested in health policies. For example, are there on time food-deprived areas or minorities? That might be an indication that her team could intervene and improve quality of care. After looking up and testing various different ideas, let me walk you through what we built for users like Tanya. So, as an approved user, I'm shown a form where I can select a combination of codelists that is specific to my question. Our users have knowledge in their clinical areas that allows them to see the most appropriate codelists for their question. And in this example, I'm selecting a solely CT codelist to identify COPD patients, and a DMD codelist to identify prescribing of antibiotic doxycycline. Users can select any codelist from OpenCodelists and described by my colleague Becky earlier. I can now build up the query and report that I want to run. We can build that request up in a paragraph, but we also get a diagram. That shows I'll be querying data on people prescribed doxycycline each month, who also have code indicating COPD anytime prior to that. I want to run this analysis on adults only, and there are a variety of demographic breakdowns I can choose from. I get back a report that provides information on basic counts, variations in practices, and all the demographic breakdowns I asked for. And we'll be doing a blog on this particular report soon if you want to learn more. What's great about this is behind the scenes, all the guarantees about reproducibility and accountability that you saw in previous presentations are still there. For example, here's the code from the OpenSAFELY Interactive report that my colleague Brian ran a few weeks ago, without ever having to touch or even be aware of the code himself. And here's a public audit trail of that code being run. So, in conclusion, because we already have such a well-built platform in place in OpenSAFELY, it's relatively easy to build tools like this on top. This will really amplify the value of delivering by allowing users like Tanya to use this data to make a real difference to the quality of care for patients. And if you'd like to see the live version of this tool in action, feel free to come find one of us during the break. Thank you very much.
Good afternoon, I'm Amir, I'm the IG man, but there's Liam up there who's also helping us. Everyone wave to Liam, he's a sterling addition to our team. So we work with NHS England to make the show flow, get on the road. So you've seen how OpenSAFELY's tech works underneath the hood, but is it really trustworthy, right? Let me ask you, do you trust me? Like, why? Is it because of how I'm dressed? Do you like it? Is it because of how I speak? Is it because I'm friendly and I look after you? Is it because I work at the University of Oxford? But how can you be so sure I'm trustworthy? I'm an academic GP. If you trust me with your secret, your health data, because you need something from me, new insights to cure your illness, when you trust me, you're basically hedging your bets, aren't you? That's what you're doing. You're hedging your bets about what you know about my integrity, my credibility, my credentials, my behaviour, and so on, that I won't tell anyone your secrets, and I will do what I said I would do. But I could divulge some of them, and you wouldn't know. And I could not do the things I said I would do, and you wouldn't know. What if we could remove or significantly, dramatically reduce that risk, the need to take a risk, and you just know that your secrets are safe, and that I did what I said I would do? Sounds good, doesn't it? Pretty good. Well, that is what OpenSAFELY does. You have to think of it in that way. That's what it does. Its features reduce the reliance on actually trusting individuals. And that's a good thing. It's really a good thing, because malicious or not, humans make mistakes. The two key privacy-enhancing features of OpenSAFELY that makes this possible are, one, researchers only see the study results. This means no data downloads or patient data extracts. OpenSAFELY takes the code to the data. Have you understood how it happens now? 50 million plus people's full GP health records. You've got to get that in your head. Like, that's enormous amount of private, secret, sensitive information. Every one of you in this room. Remain inside a truly trusted bastion of privacy, our GP health record system suppliers environment. And two, the studies are fully transparent. Researchers can only process the data by writing code. And if they wanted to sneak a peek or do something different, they would have to sneak that peek into the code for all of you to see. And from these two features emerge a really crucial benefit. So if you've understood that, the next bit makes sense. Because we now know where the data is and know how it's being used, the application process just becomes slick and easy, faster, more lightweight, where the primary focus now can be on the questions you're asking of the data and the ethics behind it. That's really important. You can't get away with that, but we want to know that precious data is being used properly and appropriately. And we can typically approve an application and onboard you under 2 weeks. We've already approved over 150 projects from over 20 organizations. So how would you describe OpenSAFELY? Well, you could say it's not just vanilla. You just know what you're going to get. Mine's salted caramel. No data disseminations, only the study results that are shared. A data log of who did what and when, and a rapid and lightweight application process. Thank you.
Okay, now on to the OpenSAFELY Copilot program. I'm Lynn Knapp. I'm a researcher at the Bennett Institute, and I'd like to introduce you to OpenSAFELY's Copilot program, our onboarding and support service program that we offer our users. Co-piloting is a fantastic way for us to offer support to our users and also increase the productivity of our platform. So, the OpenSAFELY Copilot program, what is it? To support the onboarding of external users to the OpenSAFELY platform, we have designed and developed a bespoke end-to-end onboarding and support service, the OpenSAFELY Copilot program. All external users of the platform, the pilots, get access to our program and are paired up with an experienced OpenSAFELY researcher, the co-pilots, for the duration of their projects. And the co-pilots help pilots get up and running with OpenSAFELY as quickly as possible and provide them with the experience that they need to become independent platform users. Having such close contact with our users allows us to develop and improve the platform in ways that meet the needs of our users. So in short, there are 4 main stages to our onboarding and support service program. The first stage is focused on getting users familiar with OpenSAFELY, using training materials and getting a project application approved. Now, once a project has been approved, the fun begins. Stage 2 is the point at which pilots and co-pilots have their first introductory meeting. Stage 3 is where the magic happens. In short, over a period of about 4 weeks, pilots go from deciding what data they need to requesting analysis outputs. And that's really amazing to witness. But of course, there are no expectations for a project to be completed at the end of stage 3. So that would be in 4 weeks. That would be very impressive. But by this point, pilots will hopefully have acquired the relevant experience they need to be able to fly solo. And we do, however, still offer additional support where needed until project completion. So here is the grand overview of our program. And you see that there is still support, the purple block, we provide support throughout the project. So measuring success, as of April 2023, over 50 projects have been enrolled onto our co-pilot program. These projects are split across 23 various organizations and have covered a wide range of topics, from vaccine effectiveness to the impact of COVID-19 on prescribing antimicrobials. Support is being given from one of our 12 trained co-pilots, whose lovely faces are at the bottom of this slide. You may already met some of them. And over 70% of these external projects have had one or more outputs released, with over 4,500 outputs released in total. So in summary, co-piloting is a fantastic way for us to offer support to our users and also to increase the productivity of our platform. We learn from users what works and what doesn't yet, and use that to drive and prioritize development, so that our users can undertake meaningful and exciting research. As a result, we build an analysis platform that works for more people faster. Thank you for listening.
Hey everyone, I'm Louis. I'm a researcher at the Bennett Institute, and I also run our output checking service. So the output checking service is one of multiple features we have in OpenSAFELY that allows us to maintain patient privacy whilst working with all their health records. And we think about this throughout the OpenSAFELY pipeline, but this is going to focus on research outputs specifically. So there are three main factors to this. The first is all our users are trained in some form of disclosure control. They know how to be safe researchers and how to produce outputs that are non-disclosive. Non-disclosive here being that you can't identify individuals within the results. Secondly, as you've heard already, you can only release aggregate statistics from OpenSAFELY, and the download of raw data is prevented by design. And then finally, before you can release any outputs from OpenSAFELY, they have to be reviewed by our trained output checkers, and that's the service that our output checking service provides. There's two main components to the service. The first is training. So this is deliberate training in checking research outputs for disclosivity issues, and this goes beyond the training that all the OpenSAFELY users have already had. And we've worked with the leaders in delivering this kind of training to develop a course for OpenSAFELY researchers, and we've now trained over 40 people. And importantly, all these output checkers are OpenSAFELY users, and this allows us to sort of foster a community of people that are actively engaged in disclosure control within OpenSAFELY. And then the second step is the actual service. So very simply, it starts with the researcher, and once they are ready to release their outputs, they check that there's no disclosure issues, and then they can request an output check. And the second stage here is a two-stage check by two independent output checkers, and then they make a review decision for every single output before it's released. And only once they're both happy with the outputs are they released. So what does this service look like? So since we set this up, we've handled over 500 review requests. This includes over 5,000 individual research outputs. And this graph here shows the monthly number of review requests between July 2021 and October 2022. And you can see that we've worked up to around 40 to 60 review requests per month. For these review requests, we've handled around 85% within a week, and it's often been much faster. So there's hopefully two main takeaways here. The first is this is quite a lot of work. It involves a lot of people and quite a bit of our time, but it doesn't hold back research. So by having a service like this, we can deliver both safe and efficient data access. Thank you.
Good afternoon, I'm Pete Stokes. I'm Director of Platform Development at Bennett Institute, which means principally my role is trying to find ways that we can take the brilliant tools and service of OpenSAFELY and use it beyond primary care data. Well, what I'm going to talk about today is actually our work on PPIE, or Patient and Public Involvement and Engagement, which is something else we work on. And it's really core to so much of what we do. There's no point as an institute building the really world-class tools and services that you've just been hearing about, making it possible to researchers to use data that were previously inaccessible to them, if the public don't trust it, if the patients whose data are being used actually don't support what you're doing. So we do a lot of work on PPIE to resolve that. And from the outset, when OpenSAFELY was launched, we determined that our PPIE, it wouldn't be and it wouldn't feel like a comms exercise. So if you've worked and done PPIE before, people who have given up their time to offer their views on how a service should run really don't like being just presented to and talked at, or being shown something that really has already been decided and it's just a tick box exercise, say, oh look, we've spoken to some patients. They want to be genuinely involved. So our approach to OpenSAFELY was based on the principles of learning governance and informed by the consensus statement on public involvement and engagement with data-intensive health research. And we wanted to create a system where patients and public were genuinely a part of the conversation, get really involved in the design of the platform and in its governance, how it runs, how things are shared, so that they would support it. And so to do that, we used these principles. We ran all of our engagement in an open and engaging way. It was participatory, not like this, where you're largely sitting listening. It was inclusive, so accessible to everyone, representative of the population that the NHS serves. It was discursive and deliberative. It wasn't simple yes-no questions or a single exchange of information, but actually the opportunity to develop ideas. And it's genuinely meaningful. I mean, the tools and the service that we've built has been influenced directly by the engagement that we've done. And finally, on this slide, the most important point, arguably, is it's recurring, because even when PPIE is done well, often it's only done well once. And I, that's not really a criticism. We've all done that. In my previous job, we did it as well. I think, oh, well, we've spoken to the public and they were really happy with what we were doing. And then you take that as a license to do whatever you were doing for the next 5-10 years without ever talking to anyone again. And actually, that doesn't really work. What's acceptable today might not be in 6 months' time. So we wanted to embed that ongoing engagement into our work to ensure that what we do continues to enjoy the patient and public support it has at the moment. And I'll just talk briefly about 2 key aspects of our PPIE. First, about some citizens' juries. The citizens' juries I'm going to talk about were commissioned by NIHR and NHSX and the National Data Guardian in 2021. And it's important that although OpenSAFELY was discussed by these citizens' juries, we had no part in the organisation of it. We were subject to it. And citizens' juries, if you don't know what they are, they're kind of what they sound like. It's an activity where a representative group of people are brought together with no specific prior knowledge of what they're going to be told about. And they hear details of services or policies, and they can give feedback on that. And they're shown to be really effective in helping to gauge wider public opinion. And here the aim was to evaluate 3 distinctive data sharing initiatives introduced during the pandemic: the Extended Summary Care Record, the NHS Data Store, and OpenSAFELY. And those 3 are shown on the slide. And although there are 5 columns, the middle 3 are different components of the NHS Data Store. So 3 juries, and for each of them, they heard expert witnesses, including Jess Morley from our team, talking about those initiatives, once to give a neutral description of this is how OpenSAFELY works, this is what it is, and then a more positive one to say, actually, these are the strengths, these are the benefits, these are the things that really make OpenSAFELY great, or the NHS Data Store great. And as you can see here, OpenSAFELY was comfortably the most supported of those initiatives, partly because of the strong technical design that the Seb and the team were talking about earlier, but also about the transparency that Seb, Amir and others have talked about, also the transparency of it, showing the details of what we do, the research we support, that they're available to the public, because that's critical to having that trust. And there was also for us then strong support for OpenSAFELY continuing beyond the pandemic, which is obviously what we want to hear. This service works well, it should be allowed to continue ongoing in the future for as long as possible. But it was not an unequivocal support. It was very specifically OpenSAFELY should continue beyond the pandemic if there is continued engagement with input from the public, linking to the last of those principles that it needs to be repetitive, we need to keep talking to each other. And that then finally brings us to the digital critical friends. And that's the name we've given to the group of patient and public representatives who can provide that ongoing support to design and operation of OpenSAFELY. Our digital critical ends, DCS, they're recruited during an open process, and we picked people who wanted to be as representative as possible of the population to make sure that we got a broad range of views, to make sure that it wasn't we wasn't just everybody agreeing with everything we said. And when they joined, we didn't just start by saying, right, brilliant, you're here, let's tell you about OpenSAFELY and why it's brilliant. We gave them extensive training first, not just on OpenSAFELY or even on trusted research environments more widely, but much more on the principles that underpin it. Why is health research important? Why should any of this happen when any health research actually does add risk to the use of your data? What's the importance of proper ethical scrutiny of research? To give them that good grounding, which meant they could make properly informed judgments when they were giving us advice on how we work. So the DCS now, they meet at least monthly, or often more so, and they're engaged in activities right across the platform and service, including designing the governance processes that Amir and Liam run, to the prioritisation of resources, deciding which of the tools these guys are going to build next and which are most important, and developing the communication materials that we use as well. They're represented on the oversight board for OpenSAFELY, which gives them the opportunity to make sure that the views of this group are heard by our most senior external stakeholders as well. So that's where I'm going to stop. I'm probably out of my time. That's a brief overview of the integral role that PPIE has played so far in the OpenSAFELY story, but also how it will continue to stay at the centre of what we do and how we develop the service going forward as we move beyond COVID. And now I think I'm handing back to Seb to take us through some Q&A.